Hello students, welcome to the class. So in the previous class we had started with the topic that is states of matter. We have seen different characteristics of matter. What are the different characteristics of gaseous state of matter? Yes. And now moving to the next concept, that is gas laws. So what are gas laws? What is the importance of gas laws? Okay. The gas laws are a group of laws that govern the behavior of gases by providing various relationships between the following. So it provides relationship between the following characteristics of the gases. One is it provides the relationship between volume occupied by a gas, pressure exerted by the gas on the walls of its container, then absolute temperature of the gas, amount of gaseous substance or number of moles of gas. So it provides a relationship between these four terminologies. So these are nothing but gas laws. Yes, we have certain number of gas laws. The first one is Boyle's law. It states that at constant temperature, the volume of a given mass of gas is inversely proportional to the pressure. That means, let us say we have certain volume of a mass, given mass of gas. Yes. So when you apply pressure, yes, here there is 5 kg pressure. This is the volume. If you apply pressure, what will happen? Say 10 kg pressure, what will happen to the volume? The volume will decrease. This is nothing but Boyle's law. So Boyle's law, this law was being given by Robert Boyle. He discovered the first of several relationships among pressure, temperature, and volume. So what does the gas law says? The law says that for a fixed volume amount of gas, yes, for a fixed amount of gas, yes, at constant temperature, you are not going to change the temperature because you know temperature is directly related to the kinetic energy of the molecules. Yes, they will start by moving very fast. Therefore, when you keep at constant temperature, the volume of the gas is inversely proportional to pressure. So mathematically, how can I write this? Mathematically, I will write this law as, so which law we are talking about? We are talking about Boyle's law. Correct? So what does Boyle's law says? Mathematically, I can represent Boyle's law as pressure is inversely proportional to volume at constant temperature. At constant temperature, the pressure is inversely proportional to volume, and even mass is also constant. Amount of gas, yes, for a fixed amount of gas, the pressure is inversely proportional to volume. You increase the pressure, the volume decreases. You decrease the pressure, the volume increases. Yes, remove the proportionality sign. P is equal to, introduce a constant, K into 1 by V, where K is the proportionality constant. Yes, this is another way of representing Boyle's law. Or I can take the two terms this side and I say PV is equal to K. And what is K? K is nothing but constant. That means for a particular, at a constant temperature, the product of pressure and volume for a particular gas, for a fixed amount of gas, it remains constant. Yes. If you consider two different pressures, at two different pressures, say P1 and P2, what will be the volumes of V1 and V2? We know that according to Boyle's law, P1 is equal to K by V1 and P2 is equal to K by V2. Therefore, I can write it as P1 into V1 is equal to P2 into V2. This is at two different temperature pressures and at two different volumes. So P1 V1 is equal to P2 V2 because both are equal to constant. Things which are equal to same things are equal to one another. So this is another way of representing the Boyle's law. So these are what you are seeing. These are the different ways of representing the Boyle's law. One example is this: P is equal to K into 1 by V. This is another example. P1 is equal to V1, P1 V1 is equal to P2 V2, and actual Boyle's law is this. That is, pressure for a fixed amount of gas is inversely proportional to volume. It is inversely proportional to volume. Yes. So here we have seen Here this is the volume V1 and certain pressure, say P1, 5 kg. This is the volume. If you increase the pressure, what is happening to the volume? By the piston, say the pressure volume is decreasing. So V is inversely proportional to P, or P is inversely proportional to V. PV is equal to K1. So where V is what? Volume of the gas. P is the pressure of the gas, and K1 is the constant. It is the constant. Boyle's law can be used to determine the current pressure or volume of a gas and can be represented like this also. How? P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. So this is about Boyle's law. Yes. I can give you example also. We can take an example. Suppose let me say that I have 18.10 ml of a sample of gas, and it is at 3.5 atmospheric pressure. Okay, what will be the volume of this gas if pressure becomes 2.5 atmosphere? So this is what? This is V1, and for V1 volume, this is P1, correct? They have given P2. What is the volume they are asking? So we have the formula according to Boyle's law. P1 V1 is equals to P2 V2. So I need to find V2. Therefore, V2 is equal to what? P1 V1 upon P2. How much is P1? It is 3.5 into 2.5 divided by 18.10. Correct? And the answer comes out to. So P1 V1 is equal to P2 V2. I need to find, yes. So answer comes out to what? Answer comes out, you will find the answer. You will get the answer. You will get it around cross multiply. Okay, somewhere we did wrong. So P1 V1 is equal to P2 V2. Therefore P1 by P2. So what is P1 pressure? 3.5 into, okay, V1, what is the volume? 18.10. Here it should come, divided by 2.5, P2 pressure. So answer will come out to 25.34. So this will be the volume. See, you can compare here. Pressure is decreasing, therefore volume, it is becoming increasing. So that is nothing but Boyle's law. Volume is increasing, correct? Yes. So this is an example for Boyle's law. So you can use any of the formulae. Now, isotherm for Boyle's law. See here, rather than saying, before saying isotherm, how graphical representation for Boyle's law is being done, correct? Graphical representation of Boyle's law. Yes, of Boyle's law. Now see, what does Boyle's law says? At constant temperature. At constant temperature, right? Pressure is inversely proportional to volume. So if you plot a graph of, say, if you are plotting a graph of, pressure versus volume, if you are plotting a graph of pressure versus volume, okay, so I will say I have pressure here and here is volume. When I plot a graph, what I'll get, see, as pressure increases, the volume decreases. Yes, or at high pressure, suppose pressure is high, as volume increases, the pressure decreases. You go on decreasing the pressure, what will happen to the volume? The volume will go on increasing. So I will get a curve something like this. You will get a graph like this. So you go on increasing the pressure. Sorry, you go on decreasing the pressure, the volume goes on increasing. So you are decreasing the pressure, you are coming in this direction and the volume is going on increasing. Yes or no? So this is graphical representation of Boyle's law. And you can see there, this is the relationship between, you are getting a curve for pressure versus volume at constant temperature. So since temperature is constant, this graph is called as isotherm. It is called as isotherm. So for Boyle's law, we have isotherm. What is isotherm? The plot of, or the graph obtained. Yes, the graph between pressure versus volume at constant temperature. At constant temperature is called isotherm. It is called isotherm. And you get a hyperbola. You get a hyperbola for the in the form of graph. Now you can plot pressure versus. So according to, I will take Boyle's law only. We can plot it like this also. Instead of pressure versus volume, I can plot it as pressure, and here I will plot it as 1 by V, inversely proportional. In this case, what I will get a curve like this. Is that right? I will get a curve like this. What does this mean? Pressure is directly proportional to 1 by V here. Here it is, pressure is inversely proportional to 1 by V. Here you have taken 1 by V. That means as you're moving like this, V value is decreasing, correct? Therefore, you will get a curve like this. So this is pressure versus 1 by V. Now we have one more. This is also isotherm because this is also plotted at constant temperature. Now we have one more equation for Boyle's law. We have written it as PV is equal to K, that is constant, correct? So when I plot a graph of PV versus pressure, say when I plot a graph like this, along one axis, I will take PV, that is product of pressure and volume, and along another axis, I'll take pressure. So if you plot a graph of PV versus P, see what is PV happening? PV is remaining constant. Therefore, I will get a curve like this. I will get a curve like this, which is parallel to x-axis, So these are the different graphs which are called as isotherms. Isotherm for Boyle's law. So isotherm means what? The graph for Boyle's law is a plot of volume versus pressure for a fixed mass of gas at constant temperature. Since the temperature is constant, the graph is called isotherm. Since the temperature is constant, you can see here, as I have shown, pressure versus volume, you will get a hyperbola. You will get a curve like this. As pressure increases, the volume decreases. So pressure versus 1 by V, if you take, you will get a graph like this. Yes, you will get a graph like this. Now each curve, now what we have done here is pressure versus volume only, it is bar pressure and dn cube volume at different temperatures you have taken. So at 200 Kelvin, see it is volume is decreasing like this. When you go on increasing the temperature, the curve is moving away. Yes, the curve is moving away. So each curve is a rectangular hyperbola. Yes, and corresponds to the different constant temperatures. And it is known as isotherm. Why? Temperature, therm, heat, temperature is constant. Higher curves correspond to higher temperatures. It should be noted that volume of gas doubles if pressure is half. If you make pressure half, volume of the gas will double. Yes, it depends. Inversely proportional to volume, we have said. So if you make half the pressure, the volume will become double. Please do remember this. And this. So pressure versus 1 by V at 3 different temperatures, T1, T2, T3. The straight lines obtained in the graph confirms that pressure is inversely proportional to volume. You can see here. If you take PV versus P, can you see this? What you get? You get straight line parallel to x-axis, and it is also at 3 different temperatures. Is that right? So graph parallel to x-axis confirms that at a particular temperature of the gas, the product of its volume and corresponding pressure is always a constant. It is always a constant. So at constant mass and temperature, density also you can find. You can find the density. Now, how I can relate it to density? Correct. So let me see. Relationship between density and pressure. See, according to Boyle's law, you know that PV is equal to K, that is constant. P is pressure of the gas, V is volume, and K is constant. Yes, and I hope you know how the PV is equal to K came. Yes, how did it come? We know that P is inversely proportional to volume. Remove the proportionality sign, P is equal to K by V. Take P of V that side, PV is equal to K. Yes, so by definition of density, we know that D is equal to mass by volume, correct? And here we have volume. Substitute. What will be V equal to? V equal to M by D it will be. So what you did? Substituting the equation 1, P into M by D is what? Volume is equal to K. Therefore, P by D, take mass this side. P by D is equal to K by M. A constant by a mass, and you are taking fixed mass, that is also constant. Therefore, D that side you take. Yes, I will show it better here. So we know that According to Boyle's law, P is inversely proportional. Pressure is inversely proportional to volume at constant temperature for fixed mass of gas. Correct? For a fixed mass of gas. Proportionality sign is removed, involve a constant K. Now I can write it as PV is equal to K. Yes, but we know that. What we know? We know that density is equal to mass by volume. So how can I write volume? V is equal to M by D. So I will name this as equation 1. Substitute the value of V in equation 1. So what do I get? P into, what is the value of V? Value of V is M by D. M by D, and then that is equal to constant. Because K is what? K is okay. I'll write it as K only, rather than confusing you all much. So it is equal to K. It is equal to K, right? So now what I will do here, P by D I will keep. That is equal to K by M. Why I took M this side is K is constant. M is fixed mass of gas. So mass of gas remains fixed. Constant by a constant is another constant. Let me represent it as capital K. Therefore, P is equal to K into D. When you remove a constant, when you remove a proportionality sign, you will introduce a constant. When you remove a constant, you put a proportionality sign. Therefore, I can say P is directly proportional to density. As pressure increases, the density also increases. The density also increases. That's the reason Boyle's law only is applied. At altitudes, when you climb mountains, so what happens? At altitudes, pressure is low, correct? Pressure is low. So as pressure is low, density of air will also be less. Density of air will also be less. Will also be less. That is why mountaineers, therefore mountain climbers, they carry oxygen cylinders. They carry oxygen cylinders. Yes, this is because of Boyle's law. Understood? Since pressure is directly proportional to density, at altitudes pressure is very low. Therefore, density of the air will be less. That means less amount of air will be present in a given volume. Yes. Therefore, mountain climbers carry the oxygen. So this is the relation between Boyle's law, pressure and density. Thus, I can say density of certain mass of gas, of an enclosed gas, is directly proportional to its pressure. Directly proportional to its pressure. What is the significance of Boyle's law then? Boyle's law is very significant because it explains how gases behave at constant temperature and a relation between pressure and the volume of the gas. According to Boyle's law, at constant temperature, pressure and volume of gas are inversely proportional to each other. At constant temperature, second point what we saw, density of a gas is directly proportional to its pressure. Atmospheric pressure, it is low at high altitudes. So air is what? It is less dense. Hence, lesser quantity of oxygen is available for breathing. This is the reason why mountaineers have to carry oxygen cylinders with them. They have to carry the oxygen cylinder with them. Yes, this is the significance of Boyle's law. So what is graphical representation of Boyle's law called? It is called isotherm because the graph is plotted at constant temperature. It is plotted at constant temperature. How is pressure related to density according to Boyle's law? It is directly proportional. If pressure is increased, density is also increased. If pressure is decreased, density is also decreased. Moving to the next law, that is Charles' law. How do we define Charles' law? The law states, see, this law was being given by Jacques Charles. First he studied the variation of volume with temperature in the year 1787. Boyle's law was given in the year 1662. Charles' law was given in the year 1787. Almost 100 years difference. Yes. So what does the law states? At constant pressure, the volume of a given mass of gas is directly proportional to its absolute temperature. to its absolute temperature. So it describes the relationship between the volume and the temperature. See, it is given here. So you have to take a closed system. Okay, closed system means what? See, there is only exchange of energy, no matter flows out of it. So this is before. At constant temperature, this is the volume. If this is the volume at certain temperature, it is, if you increase the volume, if you increase the temperature, what will happen to the volume? The volume will also increase. So at temperature T1, if this is the volume, see, volume at temperature T1, if you increase the temperature, the volume will also increase. This is nothing but Charles' law. Mathematically, how we can write Charles' law? Charles' law can be expressed as V is directly proportional to T. So how do we explain Charles' law? Charles' law is mathematically expressed as V is directly proportional to T at constant pressure. Very important. I'm not going to change the pressure, and mass of the substance, mass of gas is also constant. For a fixed mass of gas, we say, correct? So volume is directly proportional to temperature. Okay, so remove the proportionality sign. We introduce a constant. I can write it as K. So K into T. Yes, this is at constant pressure and mass. Or I can write it as V by T is equal to K. That is nothing but constant. Correct. If we consider at two different temperatures, suppose at temperature T1, the volume is V1, and at temperature T2, the volume is V2. Then how can I write it? V1 upon T1 is equal to constant. V2 upon T2 is equal to constant. Therefore, this is constant 1, say constant 2. Both are same. It remains constant. Therefore, V1 upon T1 is equal to V2 upon T2. This is another form of Charles' law. Another form of Charles' law. Is that right? So volume is directly proportional to temperature. I'm sorry, volume is directly proportional to absolute temperature. I'll come to it. What does that mean? At constant pressure and mass of the gas. For a fixed mass of gas, we say, right? So for a fixed mass of gas, the volume remains directly proportional to the temperature. It remains directly proportional to the temperature. Okay. Then V is equal to, remove the proportionality sign, introduce a constant. Therefore, we say V is equal to K into T. Yes, or I can write V by T is equal to K. That is constant. And at two different volumes, we can write it like that. V1 upon T1 is equal to V2 upon T2. So this is a Charles' law. This is Charles' law. Now, when I speak about, suppose let me say one of the temperature, I will take, okay, let us first view about, I'll give you one example. Okay, so example is, suppose let me say I have a carbon dioxide gas. It has a volume of 21.5 ml at 50 degrees Celsius. 50 degrees Celsius. When the amount of gas and pressure remains constant, you need to find the new volume. So V1, this is temperature T1. So you need to find the new volume if the temperature is raised to 75 degrees Celsius. So I know that V1 upon T1 is equal to V2 upon T2. Yes. So I want to find V2. So what will be the formula? V2 will be V1 into T2 upon T1, right? So what is V1? 75 degrees Celsius. 75 degrees Celsius has to be converted to what? It has to be converted to, since this is in milliliters, SI unit, you have to convert it to Kelvin. So degree Celsius to Kelvin means plus 273. So 75 plus 273 T2 into 21.5, the whole divided by 50 plus 273. 50 plus 273. Correct? This is how, when you solve it out, you will get the answer 23.16. So what is happening to the volume? When you increase the temperature, the volume is also increasing. The volume is also increasing. So this is to explain the Charles law. As temperature increases, the volume also increases, or as volume increases, the temperature also increases. Let V1 be the volume of gas at temperature T1. Pressure remains constant. If the temperature of the gas is increased to T2, then the volume also increases to V2. Therefore, V1 by T1 is equal to V2 by T2. Yes. Now, how to plot a graph for Charles law? The plot should be against volume and temperature, right? Okay, very interesting graph. So let me say this is volume, and then say this is temperature. Okay, so this is volume. This is volume. Therefore, I'll write it as bar pressure, and this is temperature in Kelvin. Correct? Both have taken in assignments. Okay. If this is so, then how do I get a curve? We know that according to Charles' law, volume is directly proportional to temperature, and this is at constant pressure. Correct? At constant pressure. So I will get a curve starting from the origin. Starting from the origin. Yes, I will get a curve starting from the origin. This is the curve what I get. Is that right? This curve for Charles' law is called isobar. It is called isobar. So why isobar? Because bar is the unit for pressure and pressure is remaining constant. So at constant pressure, the fixed amount of gas, the volume of the gas is directly proportional to absolute temperature. I'm frequently using this term absolute temperature. I'll tell you why. Okay. Now see, I will plot a graph like this. So it is called isobar. We will we'll keep this graph as it is here. So this is what I get. If I plot the graph of volume versus temperature in Kelvin scale. Now Kelvin scale, so SI unit, right? What if I plot a graph for let me say this is volume and say this is temperature, but I will mention it like this. Volume, this is temperature in degrees Celsius. What do you think? Do you think you will get a curve like this? No, I will not get a curve like this. I will get a curve. I will get a curve like this. Okay, I will show it like this better. I will get a curve from here. Yes. Why is it so? As volume increases, the temperature also should increase, right? Then why I'm not getting for this degrees Celsius? See, for Kelvin, this is correct. I understood. It is isobar at constant pressure. Volume is directly proportional to absolute temperature. But if I plot the temperature in degrees Celsius, why I am getting a curve starting somewhere at certain point in volume? The reason is, I can show you here. We have seen here, observe, yes. When I was speaking about Charles' law, this is at certain temperature T1. This is the volume of the gas V1. So it is having certain volume. When you increase the temperature, T2 is greater than T1. So when you increase the temperature, this will be the volume of the gas. What does that mean? Even at certain temperature, there is some volume of the gas or no? Yes. Yes. Even if you take at certain temp, you are not increasing, you are just taking into a cylinder, you are taking some gas. Will it have certain volume or no? Yes, it will have certain volume even if you don't increase the temperature. Yes, so therefore I am saying here, even at 0 degrees Celsius, even at 0 degrees Celsius, it will have some volume. Are you understanding? Even at 0 degrees Celsius, it will have, the gas will have some volume. You go on increasing the temperature, the volume goes on increasing. So even at 0 degrees Celsius, say temperature T1 is 0 degrees Celsius, there is some volume. Yes or no? There is some volume. I just showed you, just now we have seen. So if this temperature is T1, even if at this temperature T1 equal to 0 degrees Celsius, there is some volume. I have not increased the temperature. I have not heated this. There is some volume possessed by this gas. When I increase the temperature from 0 degrees Celsius to next higher degree Celsius, the volume is increasing. Yes, it is not that at 0 degrees Celsius, the volume is also 0. Is it so? No, there is some volume of the gas even at 0 degrees Celsius. Therefore, if you plot the graph of volume versus temperature using degree Celsius scale, even at 0 degrees Celsius, there will be some volume. There will be some volume. Then when the volume of the gas becomes 0, you want to see when it becomes 0, what you do? You drag the curve in this side. You drag the curve here. Yes, when you drag the curve here, you will get to know that. Let us see how to drag the curve. Yes, when you drag the curve here, backside, you will get to know that the volume of the gas becomes 0 at certain temperature. And that temperature is nothing but minus 273.16 degrees Celsius. Or you can just write it as minus 273 degrees Celsius. So at this temperature, the volume of gas is equal to 0. And this temperature is called what? It is called absolute temperature. It is called absolute temperature. Converted to Kelvin, plus 273, it will become 0 Kelvin. That's the reason when I plotted the graph of volume versus temperature in Kelvin scale, it started from here. So 0 Kelvin is what? It is minus 273 degrees Celsius only. Yes, so if you plot the graph of volume versus temperature in Kelvin scale, you will get a curve starting from the origin. But if you plot a graph of volume versus temperature in degree Celsius scale, it will have certain volume. Understanding? Even if you don't increase it, even if you are not increasing the temperature, the gases will have certain volume at 0 degrees Celsius also. So when the volume of gas becomes 0, it will become 0 at minus 273.16 degrees Celsius, or general minus 273 degrees Celsius, and that at that temperature the volume of the gas becomes exceptionally 0, which is highly impossible. So that temperature is called what? That temperature is called 0 Kelvin, or it is called absolute temperature. That's the reason when I was saying about Charles' law, I said at constant pressure the volume of a fixed mass of gas is directly proportional to its absolute temperature. So if you are plotting a graph versus Kelvin scale, you start from 0. You will get a curve starting from origin. But if you plot it at degree Celsius scale, then surely at 0 degrees Celsius, you will get this much volume. Then what is this volume equal to? This volume is equal to, I can plot it here. So this volume, I will denote it as V naught. And that is equal to what? 22.4 liters per mole. So what this is the volume occupied by gas at STP, standard temperature and pressure. Yes, it will have certain volume even at 0 degrees Celsius. Even at 0 degrees Celsius. Is that clear? So this is the graph for Charles' law. This is the graph for Charles' law. Yes. So you can see here. So at fixed pressure, when volume is varied, the volume temperature relationship traces a straight line on the graph, and on moving towards 0 volume, all lines intersect at a point on the temperature axis, which is at minus 273.15 degrees Celsius. Each line in the graph of volume versus temperature is known as isobar, since the pressure is constant. The least hypothetical temperature of minus 273 degrees Celsius at which a gas will have 0 volume is called what? It is called absolute 0, or it is also called absolute temperature. You can see here. So here it is 0 degrees Celsius. I'm sorry. Here it is 0 degrees Celsius. So there is some volume. Yes, when you vary the pressures, see, P1 is less than P2. So you'll get curve from here. So at minus 273 degrees Celsius, it becomes 0, or you can weave it here. See, 0 degrees Celsius, it is having some volume. Understanding? This is called as what? This is called as isobar. It is called as isobar. Yes, it is called as isobar. Okay. What is the significance of Charles' law? Air expands on heating. Yes, when you heat it, volume increases. So air expands on heating. Hence, its density decreases. So let us try to find the relationship between the Charles' law and density. We know that V by T is equal to constant. And we also know that density is equal to mass by volume. Correct? And what will be V? V will be equal to M by D. Substitute it here. So M by D upon T is equal to what? It is equal to K. Correct? So M by D into T is equal to K. Correct? Take M this side. 1 by D into T is equal to K by M. Take the reciprocal of it. So how can I write it? I can say at constant mass and pressure, the density, so D into T is equal to constant, K by M. K by M or M by K is also a constant, right? Therefore, I can, okay, I will show it better here like this. We will take it here. So according to Charles' law, V by T is equal to K, constant. And we know that D is equal to M by V. Therefore, V is equal to M by D. Substitute this value. M by D upon T is equal to K. Or I can write it as M by D into T is equal to K. Take M this side. What it will be? 1 by D into T is equal to K by M. Why I took M this side? Because fixed mass of gas. Take the reciprocal. D into T is equal to M by K. So this is all a constant. Therefore, I can write D into T is equal to constant. Say another value of K, capital K will represent. So when you take T this side, how it will get? D is equal to 1 by T. Yes, and you know that T is directly proportional to volume. So that is equal to 1 by V. Yes or no? Yes. Therefore, I can say density, there is a constant, is inversely proportional to temperature, or it is inversely proportional to volume. Yes, you increase the temperature, the density decreases. You increase the volume, the density decreases. You decrease the temperature, density increases. Yes, or I can write it as D2, sorry. I can write it as D1 by D2 is equal to T2 by T1 or V2 by V1, correct? So this is how we can write the relation between Charles' law, that is temperature and density. So density is inversely proportional. So from Boyle's law, we understood that pressure is directly proportional to density. From Charles' law, we understood that temperature is inversely proportional to density. Volume is inversely proportional to density. Yes. So using this, we can write the significance of Charles' law. Air expands on heating and hence its density decreases. So you are increasing the temperature, density will decrease. Thus, hot air is lighter than the atmospheric air. Yes or no? Hot air, it is lighter than the atmospheric air. This fact is made use of in filling hot air in the balloons which rise up for meteorological observations. Yes, that is the application of Charles' law. Application of the Charles' law. Next one, Gay-Lussac's law. It is pressure-temperature relation. The law states that at constant volume, now we are keeping volume constant, pressure of a given mass of gas is directly proportional to absolute temperature. Okay, volume is kept constant. See, both our cylinders are having same volume. So here at certain temperature T1, let me say at certain temperature T1, 0 degrees Celsius, there is some pressure P1. You increase the pressure, you increase the temperature. T2 is more than 0 degrees Celsius. The pressure also will increase. So at constant volume, the pressure of given mass of gas is directly proportional to temperature. Now question is, when you increase the temperature, why pressure will increase? Because when you increase the temperature, you are keeping volume constant. When you increase the temperature, the kinetic energy of the molecules will increase. Therefore, they will start moving very fast. when they are moving very fast, they are not having extra space to escape out. Therefore, they will hit the walls of the container. So gases exert pressure at certain fixed volume. Yes, when you increase the temperature. Therefore, when you increase the temperature, the pressure of the gas also increases. The pressure of the gas increases. So I can represent Gay-Lussac's law as, it is represented as pressure is directly proportional to temperature, or we can write it as, so Gay-Lussac's law, pressure is directly proportional to absolute temperature at constant volume and fixed mass of gas. Remove the proportionality sign. P is equal to K into T. Yes, take temperature this side. P by T is equal to K. Correct? At temperature T1, the pressure is P1. At temperature T2, the pressure is P2. So solve it out. P1 upon T1 is equal to P2 upon T2. Because things which are equal to same things are equal to one another. Yes. So P1 upon T1 is equal to P2 upon T2, and that is equal to what? That is equal to constant. That is equal to constant. Yes. So this is a relation for pressure and temperature according to Gay-Lussac's law. Now you represent it in the form of a graph. Let me see. Yes. So let us represent it in the form of graphical representation of Gay-Lussac's law. So this is x-axis. This is y-axis. I will consider one more graph here, x-axis, and this is y-axis. So what I will do here is, I have to plot a pressure versus temperature. Here I will take Kelvin scale. Yes, and pressure in bar pressure versus temperature degree Celsius scale. Correct? Okay. So what do I get? Pressure versus temperature. Since pressure is directly proportional to absolute temperature, I will get a curve like this. I will get a curve like this. Correct? When you take Kelvin scale. So Kelvin state starts from 0 Kelvin. But if the same graph is plotted using temperature in degree Celsius scale, I will get a curve somewhere like this. Yes, because even if you don't increase the temperature, you can see here, at temperature T1, you are not increasing the temperature. There is some pressure exerted by the gas molecules. Gases do exert pressure even if there is no temperature and all. Yes. Yes. Why do they exert pressure? Because they hit or collide with the walls of the containers. So even if the temperature is not increased, even at 0 degrees Celsius, there will be some pressure. But if you increase the temperature, the pressure will increase. Correct? Therefore, I will get a curve. If I plot temperature in degree Celsius scale, I will get a curve like this. Yes. And if you want to see at what temperature the pressure becomes 0, then pull the graph behind, extend the graph behind, and then what you do is, yes, then you take this curve behind. Pull this curve, drag this curve behind, you will get to know that at temperature minus 273 degrees Celsius, the pressure exerted by the gas molecules becomes 0. It becomes 0. And this temperature is called what? It is called absolute 0. Absolute temperature or absolute 0. And that is nothing but 0 Kelvin. So here I've started from 0 Kelvin. So graph I'll get from origin. If you take it in degrees Celsius, you have to extend the graph in backward direction. Is that clear? Yes. Therefore, this is nothing but Gay-Lussac's law. This is nothing but Gay-Lussac's law. So pressure of a given mass of gas is directly proportional to the temperature. Yes. So P is pressure of the gas, T is temperature in Kelvin. Then only you'll get a curve starting from the origin. And that curve which is plotted at constant volume, it is called isochore. Constant volume, it is called isochore. So we have discussed for Boyle's law, it is isotherm. because it is plotted at constant temperature. For Charles' law, it is isobar because it is plotted at constant pressure, bar, therm, heat, temperature, bar, pressure. And for Gay-Lussac's law, it is called isochore. Yes, at constant volume. So it is called isochore. Yes, it is called isochore. The relationship between pressure and absolute temperature of a given mass of gas at constant volume is called isochore. So you can see here temperature is in Kelvin. So graph starts from the origin. From the graph, it can be understood that pressure of a gas kept at constant volume reduces constantly as it is cooled until the gas eventually undergoes condensation and it becomes a liquid, and it is at 0 Kelvin. It is at 0 Kelvin. Yes. So this is about Gay-Lussac's law. This is about the Gay-Lussac's law. Next is Avogadro's law. Volume amount relationship. Okay, what does Avogadro's law says? The law states that equal volumes of all gases under same conditions of temperature and pressure contain equal number of molecules. So what does the law says? If the gas you are taking, if a fixed amount of gas you are taking, so if the volume is fixed, the same number of molecules exist in the system. So if the volumes of gases is equal, if the volume of gas is equal, suppose I've taken two different gases, oxygen and nitrogen, but I've taken same volume of oxygen, same volume, 1 liter of oxygen, 1 liter of nitrogen. It will have same number of molecules. It will have same number of molecules. Yes, that is nothing but Avogadro's law. It is Avogadro's law. So V is directly proportional to N. Yes, or you can say I will write it as V is directly proportional to N. Remove the proportionality sign. V is equal to K into N. Yes, or I can write it as V by N is equal to K. That is constant. And at two different volumes, V1 and V2, the number of N stands for what? Number of moles. V1 by N1 is equal to V2 by N2, where V is volume of the gas and it is the number of gas molecules. Then what is Avogadro constant? It is represented as Na, the number of molecules in 1 mole of gas. So Na is equal to 6.022 into 10 raised to 23 and Tt is IC. Or you can write it as molecules. Number of molecules. So equal volumes of all gases at standard temperatures and pressures contain equal number of molecules. They will have equal number of molecules. Therefore, you can write it as, for example, I will show you. Let me say I have example, say hydrogen gas combines with oxygen to form water. Say 2 molecules, I'll take it 2 here, correct? Okay. So 2 moles of hydrogen gas combine with 1 mole of oxygen to form 2 moles of water. Or I can say 2 volumes of hydrogen gas combines with 1 volume of oxygen gas to form 2 volumes of water. Or I can say 2 liters of hydrogen gas combines with 1 liter of oxygen gas to form 2 liters of H2O. Or I can say 6.022 into 10 raised to 23 molecules of hydrogen. So 2 into 6.022, 6.022 into 10 raised to 23 molecules of oxygen will give 2 into 6.022 into 10 raised to 23 molecules of H2O. Yes, what does this law states? Yes, V is directly proportional to N. Equal volumes of all gases, any two gases at same temperature and pressure, they will contain equal number of molecules. 1 mole of any gas. 1 mole of any gas contains same number of molecules. And what is that same number? It is Na. That is nothing but Avogadro number, 6.022 into 10 raised to 23 molecules. And by this law, must occupy the same volume. It must have the same volume at the given temperature and pressure. So the volume of 1 mole of gas at constant temperature and pressure. The volume of 1 mole of gas is called what? It is called molar volume. It is called molar volume. So here it will have same volume. What is that volume called? Molar volume. It is denoted like this, Vm. And which is equal to, molar volume is equal to what? 22.4 liters at STP, standard temperature and pressure. So if you take 1 mole of any gas, it will have same number of molecules and it will have same volume. If I say I have taken here, so I have taken 3 gases. So let me say I have 3 gases here, and let me say I have taken water vapor also. Yes, okay. So let me say here I have taken H2O gas. Here I have taken N2. Here I have taken O2. Here I have taken CO2. Yes, all of them I'll say I have taken 1 mole of H2O, 1 mole of N2, 1 mole of O2, and 1 mole of CO2. Yes, so 1 mole of H2O will have how many molecules? 6.022 into 10 raised to 23 molecules of water. 1 mole of N2 will have 6.022 into 10 raised to 23 molecules of N2. Or 1 mole of O2, 6.022 into 10 raised to 23 molecules of O2. 1 mole of CO2, 6.022 into 10 raised to 23 molecules of CO2. So if I have 6.022 into 10 raised to 22 molecules, 23 molecules of H2O, how much liters it will be? It will be 22.4 liters. Understanding? If I have 6.022 into 10 raised to 23 molecules of N2, how much liters? 22.4 liters. 6.022 into 10 raised to 23 molecules of O2, it will be also 22.4 liters. So 6.022 into 10 raised to 23 molecules of CO2, it will be also 22.4 liters. So equal volumes of any gases will contain equal number of molecules, and that is given by Avogadro's law, and that equal number of molecules is nothing but Avogadro's constant, Na. It is nothing but 6.022 into 10 raised to 23. So Avogadro's law says that equal volumes of any gas, equal volume of any gas at STP contain equal number of molecules, contains equal number of molecules. Yes, understood. And that comes under mole concept. So if you have 1 mole, it will be equal to Avogadro number, as we have discussed. I've told you many times. I hope this concept is clear, right? So when we say 1 mole, yes, I'll better show you all like this. So suppose I say I have So I'm repeating it again. So 1 mole is equal to what all things? Okay, we will study it in the form of graph. We'll better understand it in the form of graph. Okay, so first let us see what all it can cover. So here I have 1 mole. So 1 mole is equal to what? It is equal to atomic mass. Okay, before that, 1 mole is equal to what? 6.022 into 10 raised to 23 entities I will write. That means if I say I have 1 mole of atoms, it will be equal to 6.022, that is Avogadro number of atoms. If I say 1 mole of molecules, it will be equal to Avogadro number of molecules. If I say 1 mole of ions, it will be equal to Avogadro number of ions. Therefore, for atoms, molecules, and ions, generally I will use the term entities. Okay. Then 1 mole is equal to, it is equal to atomic mass of element. So if I say I have 1 mole of sodium, it will be equal to how much grams? It will be equal to 23 grams. Atomic mass of sodium is 23. 1 mole of hydrogen, it will be equal to 1 gram. Yes, so it is equal to atomic mass of element. 1 mole is equal to molecular mass of a compound or a molecule. Example, if I say 1 mole of hydrogen gas, it will be equal to 2 grams. So 1 into 2. If I say 1 mole of water, it will be equal to 2 plus 16 is 18 grams. It is equal to molecular mass. 1 mole is equal to molar volume. It is equal to molar volume. That is equal to 22.4 liters. So if I say 1 mole of oxygen gas, then it is equal to 22.4 liters. If I say 1 mole of carbon dioxide gas, it will be equal to 22.4 liters. Understanding? So 1 mole is equal to all these entities. 1 mole is equal to all these entities. So this is everything regarding 1 mole. So mole concept we call it as. So what does Avogadro? So I hope this concept is clear. 1 mole is equal to what? It is equal to 6.022 into 10 raised to 23 entities, molecules, atoms or ions. And that was given by Avogadro. Therefore, it is in his honor, it is denoted as Avogadro number or Avogadro constant. It is denoted as Na. Then we have atomic mass of the element. If you say if you have 1 mole of something, of an element, then that is equal to atomic mass of that element. If you say 1 mole of some molecule, that will be equal to the molecular mass of that element. If you say 1 mole of any gas, it will be equal to 22.4 liters. And this is nothing but Avogadro law. What it says, equal volumes of any gas at STP. At STP, equal volumes of any two gases or any gas will have equal number of molecules. Yes, therefore, if you have a gas, say 22.4 liters of gas, it will have Avogadro number of molecules. It will have Avogadro number of molecules. So according to Avogadro's law, V is directly proportional to N. Remove the proportionality sign, V is equal to K into N. This is at standard temperature and pressure. So V by N is equal to what? It is equal to K. At two different volumes, V1 by N1 is equal to V2 by N2. Is that right? So this is how we represent Avogadro's law. So this can be also expressed as the molar. So you can express it in different form also. Molar gas volume, 22.4 liters, correct? At given temperature and pressure is a specific constant, independent of nature of gas. So it is not dependent on the nature of gas. What type of gas you are taking, it is not dependent. So molar volume of a gas, for a fixed volume of gas, it at temperature, pressure constant, it is specific constant independent. Therefore, I can write it as molar volume is equal to specific constant. And that is equal to what? That specific constant is equal to 22.4 liters. And this is at STP, or you can say NTP. I hope you know STP or NTP means what? Standard temperature and pressure, or normal temperature and pressure. So this is Avogadro's law. What is this? Avogadro's law. So here it is represented where P1 is volume of ideal gas and N is represented as number of gas molecules. This is Avogadro's number. Let us take one problem and see how we can solve it out. Okay, I'll just tell you. Say temperature and pressure are constant. 6.0 liter of gas is known to contain 0.975 moles of it. So if the amount of gas is increased to 1.90 moles, what will be the volume? So this is V1, this is N1. They have asked you to find V2 and N2 is given. So according to Avogadro's law, we know that V1 upon N1 is equal to V2 upon N2. So I want to find V2, therefore I can write V1 N2 upon N1, correct? V1 N2 upon N1. What is V1? 6.0 into N2 is 1.9 upon N1, 0.975. Solve it out, you will get the answer 6 into 1.9. So you'll get the answer around 11.7 liters. You get the answer around 11.7 liters. Yes. Even a pressure for Gay-Lussac's law also, I had not given the question. And one example we can consider for Gay-Lussac's law. See, Gay-Lussac's law is what? We know that P is directly proportional to T. So P1 upon T1 is equal to P2 upon T2. This is Gay-Lussac's law, right? So determine the pressure change when at constant volume. Gas at 2 atmosphere. So P1 is 2 atmosphere is heated from T1 and T2 is given from 30 degrees Celsius to 40 degrees Celsius. 30 degrees Celsius to 40 degrees Celsius. Convert it in Kelvin scale. So I want to find P2, right? So from the equation, P2 will be equal to what? P2 will be equal to P1 into T2 upon T1. Yes. Correct. So P2 into T1, correct or no? P1 upon T1 is equal to P2 upon T2. So P2 will be equal to what? P1 into T2 upon T1. So P1 is 2 atmosphere into 30 plus 273 upon, T2 it should be. So T2 is 40 plus 273 upon 30 plus 273. Solve it out, you will get the answer around 2.0. 2.07. So pressure has increased. Yes, as temperature has increased, the pressure also has increased. Correct? You can see that is nothing but Gay-Lussac's law. Okay, so we have studied regarding the gas laws, which give the relationship between volume, pressure, then temperature, and the number of moles. So here, let me condense everything. We have studied according to Boyle's law. What does the law says? The law says that volume is inversely proportional to pressure at constant temperature and mass. And the graph plotted is called what? It is called isotherm. Okay, then according to Charles' law says what? Charles' law says that volume is directly proportional to absolute temperature at constant pressure and mass. And the graph plotted is called what? Isobar, because at constant pressure. Then according to Gay-Lussac's law, what does the law says? The law says that pressure is directly proportional to temperature at constant volume and mass. Correct? And the graph plotted is called isochore. It is called isochore. Then according to Avogadro's law, what does Avogadro's law says? It says that equal volumes of any gas at STP contain equal number of molecules at constant temperature and pressure. Yes, at constant temperature and pressure. So this is nothing but Avogadro's law. So these are the 3 laws what we have discussed. In the next class, we will go to combination of 3 laws, all these laws. These are the 4 laws what we have discussed. In the next class, we'll discuss the next concepts. That is, combination of all these laws gives some equation for the gases. And further, we will discuss some other concepts related to the gaseous state. Hope you have understood all the laws. Please do practice the laws. Then it will be helpful for solving the different questions and for understanding the next concepts also. For now, thank you.